Hi everyone, good day and welcome to Maths and Physics with Mr. Simons. Starting here with grade 10 work on algebraic expressions, and this is where work starts for grade 10. So we'll be doing classwork on number systems and classification. Very important that we know which number system we're working with and if we can classify the numbers before we even do any work on that numbers, right? So what you're going to be working through and what you should know. Alright, so for the number system, we must be able to classify the numbers, say whether they are real, non-real, irrational, rational, etc. Alright, then same question that we test, converting a decimal fraction to a common fraction. Right, then rounding off for approximation and estimation, and then establishing between which two integers a third line. Right, so there's a small checkbox for you. This is just on a number system and what you need to know, right? So tick off what you can and can't do so that you know what you need to re-practice, right? So the real number system, which is what we mainly work on from now till grade 12, starts off with the natural numbers, also known as counting numbers. So it should naturally make sense to you. When we initially started counting, we looked at the trees and be like, oh, that's 1 tree, there's a second one, third one, fourth one, etc. So we say natural numbers, it's just how we naturally count. 1, 2, 3, 4, 5, 6, 7. No minus 1, no 0, etc. Right? So natural numbers have no 0 and they start from 1 and we're counting or increasing by 1s. Whole numbers, eventually, we discovered or created the number 0. Right? So whole numbers, simply, it's natural numbers, but starts from 0. So now we're counting 0, 1, 2, 3, 4, etc. Then we have integers, which form a very important part, especially like in accounting where we have debits and credits, ATM, banking, balances, and so on. When people have loans with the banks or overdrafts, they have negative values. If they have their own money saved, it's a positive value, etc. So integers are represented by the symbol Z. Start from, it's basically all my natural numbers, positive and negative, including 0. So minus 3, minus 2, minus 1, 0, 1, 2, 3. Alright, so those are my basic numbers. Right, then we have what we call rational numbers. Now rational numbers is any number that can be written as a fraction, meaning a over b, where a and b are integers, and p is not equal to 0. So if that is 0, it becomes undefined. Something we will test even up to grade 12. Right, so we need to know that the denominator can never be 0, because then we have an undefined equation. Right, so symbol for rational numbers, Q. There, minus 4, minus 1.5, negative 0.73, 0, 3 over 4, 1, square root 9, 4.5, 9.732 reoccurring. So all of this can be written as, that would be 9 and 732 over 999. There to give you, square root 9 is 3, but 3 is the same as 3 over 1. So you see I can write them all as fractions, therefore they all is considered rational numbers. So rational numbers include proper and improper fractions, terminating and recurring decimals. Right, so that is rational numbers. Irrational numbers, right, Q dash, numbers that cannot be written in the form a over b. So square root 3, pi, square root 8, 0.121314. See, in there we have no recurring, there's no 1, 2 again, it's 12, 13, 14. So normally, square roots of all non-perfect squares. When I say non-perfect square, 3 is not a perfect square number. We don't know naturally which number times itself will give me 3. Same applies by 8. I can't say 4 times 4 is 8. No? So therefore 8 is non-perfect. So if I find the square root of a non-perfect, it has non-reoccurring decimals, therefore it's considered irrational. So give you examples, 6.421 is a finite decimal fraction, also known as a terminating fraction. So it stops by 421. So I can write 421 as a fraction. Same here, 37 over 99. So therefore, these are considered recurring decimal fractions, rational. Therefore, terminating and recurring decimal are known as rational number. However, if I write 6,421 dot dot dot, I'm saying there's no values that recurring, it's infinite. Non-recurring decimal fractions, therefore irrational. Right, but we're going to do some examples on it and you will see what we mean with it. Right, then we have non-real numbers. It forms part of the complex number system, which you don't do at school. These are square roots of negative values. So we have a square root of negative 16, square root of negative 36, etc. So as soon as we find the square root of a negative value, we're dealing with what we call non-real numbers. Alright? So that there, grade 11, we're going to use this to solve what we call nature of roots. Now for grade 10, you just need to know they are non-real. Right, then we have other types of numbers. We have prime numbers, which you've done in grade 9. It has only two factors, itself and 1. So 2 only has the factor 1 and 2. So 2 divided by 1, 2, 2 divided by 2, 1. There the same applies by 3. It only has the factor 3 and 1. 5 has the factor 5 and 1. 13 has the factor 13 and 1. So there's just a basic list of prime numbers we're going to work with. Say composite numbers, it has more than two factors. So 4 has the factor 1, 2, and 4. 6 has the factor 1, 2, and 3. Look at 10. 10 has the factors 1, 2, and 5. So because it has more than two factors, they are referred to as composite numbers. Perfect square numbers. And I do a whole series of work on this, so you need to know when you say perfect square, a square means the sides are equal in length. So perfect square numbers, 1 times 1, sides are the same, 2 times 2, 3 times 3, etc. That gives me 1, 4, 9, 16, and 25. Those are called my perfect square numbers. Right? Square roots of those numbers, and we need to know the first 13 square roots. So square root 1, 4, 9, 16, 25, 36, all the way to 169. I need to know the square roots of 1 up to number 13. 13 times 13, 169. 12 times 12, 144. 8 times 8, 64, etc. For perfect cube numbers, we need to know the first 7 perfect cube numbers. So 1 times 1 times 1, 1, 2 times 2 times 2, 8, 5 times 5 times 5, 125. And we need to know all the way up to 7, 7 times 7 times 7 gives me 343. We say cube roots of them. Cube root of 1 is 1, cube root of 8 is 2, 7, 3, 64, 4, cube root 125, 5, 216, 6, 347, 343, 7. Right? So those are your perfect cube numbers. So these are the numbers we need to learn and know because that's what we're going to work on. Next slide, we'll do some exercises on this work to show you how we test it and what you can expect coming up in exam based on this. Okay? Wish you nothing but the best. Bye.